assemble pipes, valves, and test for leakage and functionality of the valves.
Topics: Assemble pipe with standard fittings. Test for leakage and functionality of valves. Tools and equipment required. Identify the tools and equipment used in fitter section. Record the names of tools, do's and don'ts of each tool. Record the names of the industries where the fitters are employed. Tools and equipment required. Pipe wrench, bucket, pressure gauge. Safety precautions in fitting. Demonstration activities, shop talk with safety. Safety attitude development of the trainee by educating them to use personal protective equipment. Identify personal protective devices. Interpret the different types of personal protective devices. Eye protection. Safety glasses. Foot protection. Safety shoes. Dust and fumes. Respirators. Hands safety. Gloves. Head safety. Helmet. Hearing protection. Earplugs. Clothing. Safety jacket. Prevent from falling. Safety harness. Test for leakage and functionality of valves. Prepare the pressure testing machine. The pressure testing machine consists of pump, pump handle, pressure gauge, stop valve, drain valve. Task 2. Test for leakage and functionality of valves. Prepare the pressure testing machine. Fill up the water in the pressure testing machine. Connect the pressure testing machine tube with the pipe fittings assembly to be tested. Apply pressure to test the pipeline completely without any air. Pump the water into the pipeline. Trace the pipelines to find leakages. Tight the pipe fittings properly if leakage is there. Apply pressure again and again to test the pipe fittings assembly for proper functioning. Remove the hose pipe from the pressure testing machine if leakages are not there. Test for leakage and functionality of valves. Prepare the pressure testing machine. Connect the pressure testing machine tube with the pipe fittings assembly to be tested. Fill up the water in the pressure testing machine. Before connecting the hose pipe with the pipe fittings, plug all the openings in the test section with the pipe nipple socket and plug. Apply pressure to test the pipeline completely without any air. Pump the water into the pipeline. Trace the pipelines to find leakages. Tight the pipe fittings properly if leakage is there. Apply pressure again and again to test the pipe fittings assembly for proper functioning. Apply pressure to test the pipeline completely without any air. Remove the hose pipe from the pressure testing machine if leakages are not there. While fixing the pipe fittings with pipelines, use proper materials to avoid leakages. Don't over-tighten the pipe fittings while fitting with pipes. Recap: tools and equipment required. Safety precautions in fitting.
Now we have learnt to assemble pipe with the standard fittings, test for leakage and functionality of the valves.
Hope you had a clear understanding on this technical process. Thank you.
Test for leakage and functionality of valves.
Hello everyone. Today we'll be looking into the process of fitter practical sessions to fit and assemble pipes, valves and test for leakage and functionality of the valves.
Topics: assemble pipe with standard fittings. Test for leakage and functionality of valves. Tools and equipment required. Identify the tools and equipment used in fitter section. Record the names of tools, do's and don'ts of each tool. Record the names of the industries where the fitters are employed. Tools and equipment required. Pipe wrench, bucket, pressure gauge. Safety precautions in fitting. Demonstration activities, shop talk with safety. Safety attitude development of the trainee by educating them to use personal protective equipment. Identify personal protective devices. Interpret the different types of personal protective devices. Eye protection, safety glasses, foot protection, safety shoes, dust and fumes, respirators, hands safety, gloves, head safety, helmet, hearing protection, Earplugs. Clothing. Safety jacket. Prevent from falling. Safety harness. Test for leakage and functionality of valves. Prepare the pressure testing machine. The pressure testing machine consists of pump, pump handle, pressure gauge, stop valve, drain valve. Task 2. Test for leakage and functionality of valves. Prepare the pressure testing machine. Fill up the water in the pressure testing machine. Connect the pressure testing machine tube with the pipe fittings assembly to be tested. Apply pressure to test the pipeline completely without any air. Pump the water into the pipeline. Trace the pipelines to find leakages. Tight the pipe fittings properly if leakage is there. Apply pressure again and again to test the pipe fittings assembly for proper functioning. Remove the hose pipe from the pressure testing machine if leakages are not there. Test for leakage and functionality of valves. Prepare the pressure testing machine. Connect the pressure testing machine tube with the pipe fittings assembly to be tested. Fill up the water in the pressure testing machine. Before connecting the hose pipe with the pipe fittings, plug all the openings in the test section with the pipe nipple socket and plug. Apply pressure to test the pipeline completely without any air. Pump the water into the pipeline. Trace the pipelines to find leakages. Tight the pipe fittings properly if leakage is there. Apply pressure again and again to test the pipe fittings assembly for proper functioning. Apply pressure to test the pipeline completely without any air. Remove the hose pipe from the pressure testing machine if leakages are not there. While fixing the pipe fittings with pipelines, use proper materials to avoid leakages. Don't over-tighten the pipe fittings while fitting with pipes. Recap: tools and equipment required. Safety precautions in fitting.
Now we have learned to assemble pipe with the standard fittings. Test for leakage and functionality of the valves.
Hope you had a clear understanding on this technical process. Thank you.
Visual inspection for visual defects, for example dents, surface finish.
Hello everyone. Today we'll be looking into the process of fitter practical sessions to inspect for visual defects such as dents and surface finish.
Topics. Objectives. At the end of this exercise you shall be able to visual identification of defects on various metal sections. Safety precautions in fitting. Demonstration activities, shop talk with safety. Safety attitude development of the trainee by educating them to use personal protective equipment. Identify personal protective devices. Interpret the different types of personal protective devices. Eye protection. Safety glasses. Foot protection. Safety shoes. Dust and fumes. Respirators. Hands safety. Gloves. Head safety. Helmet. Hearing protection. Earplugs. Clothing. Safety jacket. Prevent from falling. Safety harness. Objectives. At the end of this exercise you shall be able to visual identification of defects on various metal sections. Part 1. Identification of defects. Wavy edges. Type of defect. Fibers at the edges are longer than fibers at the center. Cause of defect. Result from concave roll bending and elastic deformation. Corrective action. Hydraulic jacks are used, which control the elastic deformation of the rolls according to the requirement. Small diameter rolls are used. Edge cracks. Type of defect. Various cracks and metal cutted pieces at the edge of the metal sheet. Cause of defect. Secondary tensile stresses induced at the workpiece surface by inhomogeneous deformation. Corrective action. Roller leveling or stretch leveling under tension using edge rolls. Center cracks. Type of defect. Small uniform cracks in the middle of the metal sheet. Cause of defect occurs due to high tensile stress. Corrective action. Cambering of rolls can prevent such defects. Alligatoring. Type of defect. Separation of the layer giving rise to the opening of the slab which looks like an alligator mouth in the opening position. Cause of defect: due to the non-homogeneous flow of material occurring at the center, metallurgical weakness in the metal, due to the presence of inclusion along the center line of the slab. Corrective action: cambering of rolls can prevent such defects. Surface defect. Cause of defect: this type of defect is caused due to issues in casting or casting die. Corrective action: proper casting and checking the die for proper finish. Inclusion. Inclusion defects of castings are defects such as slag of oxides and other substances generated in the Ludlay by the reaction and sand of molds, and the cores that flake away and are included in molten metal, flowing into products and up pairing on the surfaces of parts as nonmetallic inclusions. Blister. During injection molding, air can become entrapped within the mold part, causing a blister to form on the part surface. This often occurs where two-flow fronts meet because of variation in part wall thickness or geometry. Pits. Pitting presents as random smooth depressions or shallow pits in the casting. This defect indicates that oxygen reacted with the chrome in metal. This reaction is more prevalent with certain metals. Embedded scale. Various types of surface defects, scale defects, result especially from the deformation and breakage of scale. This paper describes the formation behavior of scale on ordinary. Cracks. Hydrogen cracking may also be called cold cracking or delayed cracking. The principal distinguishing feature of this type of crack is that it occurs in ferritic steels, most often immediately on welding or a short time after welding. Sliver. Some of the defects in steel products include quench cracks, roll marks, overlaps, oxide scales, and pinchers. Scab. Scab is sand casting defect caused due to improper ramming of molding sand. Scab refers to the rough, thin layer of a metal protruding above the casting surface on top of a thin layer of sand. Kindly note the nature of the defects of the material in the following table and get it checked by your instructor. The nature of the defect can be classified into two major types. 1. Dents, rolling defects. 2. Surface finish, casting defects. Recap. Safety precautions in fitting.
Now you have learned to visually identify the defects on various metal sections.
Hope you had a clear understanding on this technical process. Thank you.
Measuring, checking and recording in control chart.
Hello everyone. Today we'll be looking into the process of fitter practical session to understand measuring, checking and recording in control chart.
Topics. Objectives. How to measure. Measure the dimension 26.00 mm of gap gauge go end tool. Various dimension. Check and measure all the 20 components and plot the same reading on the control chart. Safety precautions in fitting. Demonstration activities, shop talk with safety. Safety attitude development of the trainee by educating them to use personal protective equipment. Identify personal protective devices. Interpret the different types of personal protective devices. Eye protection. Safety glasses. Foot protection. Safety shoes. Dust and fumes. Respirators. Hands safety. gloves, head safety, helmet, hearing protection, earplugs, clothing, safety jacket, prevent from falling, safety harness, measuring, checking and recording in control chart. How to measure the dimension 26.00 millimeters of the gap gauge go end tool various dimension. How to check. At the end of this exercise, you shall be able to measure the dimensions and prepare the chart. Instructor has to prepare 20 components as per the drawing and keep them ready. Ask the 20 trainees to check and measure all the 20 components and plot the same reading on the control chart. Each trainee measures the dimension 26.00 millimeters of the gap gauge go end and notes down the value against his roll number in table. Based on the data available in table, ask the trainees to record it on the chart. Draw the curve according to the mark in the chart. Submit the chart to the instructor for checking. Enter each trainee's component dimension 26.00 plus 0.010 to 0.000. Note: the control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a center line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data. Topic 6: Measuring, checking and recording in control chart. Measure the dimension 26.00 millimeters of gap gauge go end tool. Check and measure all the 20 components and plot the same reading on the control chart. Recap. Safety precautions in fitting.
Topic 6. Now we have learned how to measure, check and record in the control chart.
Hope you had a clear understanding on this technical process. Thank you.
Hello everyone, we are going to discuss fixtures in drilling.
Objectives. At the end of this video, you will be able to 1. Locate the workpiece in a jig. 2. Drill the hole on MS channel. 3. Check for the accuracy. Let us discuss the machineries and tool required for this practical. Lathe machine. 1. Drilling machine. 1. Bench vise. 1. Drill bits 5 to 12 mm 1 set. Vernier caliper 1. Steel rule 300 mm 1. File flat 10 inch 1. Let us discuss on fixtures for drilling. A fixture is a production tool used to locate accurately and to hold securely one or more workpieces so that the required machining operations can be performed. A fixture should be securely fastened to the table of the machine upon which the work is done. The main purpose of a fixture is to locate the work quickly and accurately, support it properly, and hold it securely. Common types of fixtures used for the machining operations are 1. Milling fixture. 2. Turning fixture. 3. Grinding fixture. Base plate. The base plate for a milling fixture is provided with tenons at its bottom for proper location of the fixture with the machine table through T-slots. 2 or 4 hold-down slots are provided in the base plate for rigid clamping of the fixture with the machine table. Standard clamps and locators. These are provided for clamping and locating the workpieces with the fixture. As in the case of drill jigs, the clamps used in the fixtures are very rigid and sturdy. The setting blocks. These are used to position the fixture and work relative to the cutter before machining. A feeler is introduced between the cutter and the setting faces of the block for correct positioning of the cutter with the fixture. Balancing weight. This is used dynamically, balancing the irregular workpiece fixed to the turning or cylindrical grinding fixture. In the case of a turning fixture, normally the base plate of the fixture is clamped to the face plate. Vise fixture. Standard machine vices attached with special jaws provide an easy method of holding parts for machining. Other types of tooling used for positioning parts relative to each other for fabricating purposes are also commonly referred to as fixtures. Bending fixtures, assembly fixtures, and welding fixtures are examples of this type. The construction of a fixture depends upon the machining and fabricating methods employed. Classification of fixtures. Fixtures are classified by the type of machine on which they are used. If a fixture is made for a milling machine, it is called a milling fixture. Some of the most commonly used fixtures are turning fixture, milling fixture, welding fixture, boring fixture, assembly fixture, inspection fixtures, etc. The elements of jigs and fixtures are 1. Location, 2. Clamping, 3. Tool guiding or setting, 4. Body base or frame. Types of fixtures. Plate fixture. These are the simplest form of fixtures. It is made from a flat plate which has locator and clamps to locate and hold the part. Angle plate fixture. This fixture is used for machining the part at right angle to the locator. Modified angle plate fixture. This fixture is used for machining the part at angles other than 90 degrees. Vice jaw fixture. This fixture is used for machining small parts. The standard vice jaws are replaced with jaws that are made to suit the work. Indexing fixtures. These fixtures are used for parts that require machining on evenly spaced surfaces. Use of fixtures. A great deal of importance is placed today on improving productivity in manufacturing processes. Application of jigs and fixtures has contributed a lot towards this direction. Fixtures are devices used in manufacturing or assembling. They also facilitate in carrying out special operations accurately. Fixture is a production tool that locates and holds the workpiece. It does not guide the cutting tools, but the tools can be positioned before cutting with the help of setting blocks and feeler gauges, etc. Fixtures of different types are made for 1. Milling, 2. Turning, 3. Grinding, 4. Welding, 5. Assembly, 6. Bending, etc. Let us discuss in practical. Step 1. Make top plate. Step 2. Make hook bolt. Step 3. Make knob. Step 4. Make jig bush. Step 5. Drill jig assembly. Step 6. Remove the top plate from the plate jig. Step 7. Locate component between the hook bolt and touch with stopper pin. Step 8. Clamp the top plate with the knobs. Step 9. Drill diameter of 6 by 4 numbers. Step 10. Remove the top plate. Step 11. Take out the component from the jig. Step 12. Check the component with a vernier caliper.
In this video, we have discussed the basics of fixtures, their features and type, how to locate a workpiece and a jib, drill the hole on MS channel and check for accuracy. Hi everyone, in this video, we are going to discuss how to mark out angular outlines, file and fit the insert into the gaps.
Objective. At the end of this video, you will be able to 1. Mark an angular outline on part A and B with an accuracy of plus or minus 5 minutes. 2. File part A and B, maintain the accuracy of H7 by G6 for fitting. 3. Fit inserts. Let us discuss the tools and materials required to do these practicals. Vernier height gauge 1. Vernier bevel protector 1. Vernier caliper 1. Steel rule 300 mm 1. Scriber 1. Flat file 12-inch 1. Dot punch 1. Ball peen hammer 250 gram 1. Let us discuss the job sequence for this practical. Step 1. Cut the raw materials as per the dimensions. Step 2. File right angle and mark off part A and B with vernier height gauge and vernier bevel protractor. Step 3. Punch on the marked lines or outlines. Step 4. Remove unwanted materials by hacksawing and chain drilling. Step 5. File part A and B with a linear accuracy of plus or minus 0.02 mm and angular of plus or minus 5 minutes. Step 6. Checking the angular dimensions by vernier bevel protractor. Step 7. Fit part A and B and finish. Safety. 1. Do not mark angular dimensions or angle by scale or set square while marking. 2. Do not use hammer for fitting. Let us do the job sequence in practical. Step 1. Select the mild steel flat material to do this job and ensure the selected MS is flat and smooth. Also, ensure that the thickness of the MS flat is 5 mm and the width is 50 mm. Step 2. Place the MS flat on the workbench with the help of the tri-square. Check the outer side of the flat for straightness. If the outer side of the flat is not straight, mark a straight line with the help of the scriber. Step 3. With the help of the vernier scale, measure 72 mm of length on the flat and draw a line using the scriber until the line is visible. Step 4. Now, fix the workpiece on the bench vise and keep it tight using lever so that the vise holds the job tightly. Step 5. With the help of hacksaw frame, cut the flat for 72 mm. Step 6. Now, turn the workpiece facing the excess material on the top of the vise and start filing the surface of the workpiece with the flat file so that the excess material on the surface is removed. Step 7. Now, use a vernier caliper and measure the MS piece for length and breadth, which are 72 and 50 mm respectively. Step 8. Unlock the lever in the bench vise. Set the workpiece between the jaws and begin filing the surface of the workpiece with the flat file. Step 9. The workpiece is taken to a vernier height gauge after filing. Step 10. In order to observe the marking that will be made by the vernier height gauge, chalk is wiped against the workpiece. Step 13. Marking is done as shown in the sketch while holding the workpiece up against the angle block, 5 mm and 18 mm as per the given dimensions. Step 14. With the help of the vernier bevel protractor, mark the angles for 80 and 70 degrees as per the given dimension. Step 15. After doing the marking with a vernier height gauge and vernier bevel protractor, mark the line with the help of a steel ruler and scriber. Step 16. Putting the workpiece on the hand will make small markings along the lines with the help of the dot punch and ball peen hammer, allowing cutting to be done with ease. Step 17. Holding the workpiece at an angle between the bench vise's jaws will allow for straight cutting. Step 18. Cutting is done by hacksaw frame and ensure cutting is not done beyond the punch markings. Step 19. After cutting, you will have two jobs, parts A and B. Step 20. Place the job pieces between the jaws of the bench vise and start filing with the help of the file to smooth the workpiece. Step 21. Both parts A and B are filed. Step 22. Check the alignment by gathering the two workpieces A and B. Step 23. Take a vernier caliper and check for accuracy. Check the dimensions of each and every shape of both part A and part B workpieces. Step 24. Take a vernier bevel protractor and check the angle accuracy 70 and 80 degrees as per the sketch. Step 25. Check for the clearance between the two parts A and B as per the standards of H7 by G6. H7 by G6 fit gives a minimum clearance of 0.007 mm and a maximum clearance of 0.041 mm.
In this video so far, we have discussed how to mark out angular outlines, file and fit the insert into the gaps as per given dimension and sketch, maintaining the accuracy. I hope after watching this video, you will be able to do it practically. Hello everyone. In today's video, we'll discuss the exercises on finished materials such as stainless steel, copper, brass and aluminum, such as marking out, cutting to size, taping, drilling, etc. without damaging the surface of the finished articles.
Objective? At the end of this video, you will be able to 1. Mark on the aluminum, brass, copper with vernier height gauge. 2. Cut extra metal using hacksaw. 3. Drill countersink, counterbore and ream. 4. Tap, finish and deburr. Let us discuss the tools and materials required to do these practicals. Drilling machine 1. Vernier height gauge 1. Vernier caliper 1. Steel rule 300 mm 1. Drill bit 6 mm to 12 mm 1 set. Reamer tool 6 mm 1. Counterbore 6 mm 1. Tap and die set 1. Flat file 12 inches 1. Dot punch 1. Ball peen hammer 250 gram 1. Let us discuss the job sequence for this practical. 1. Check raw material. 2. File two adjacent side and on flat surface. 3. Mark the size of 74 mm by 48 mm outer line. 4. Punch identification mark. 5. Remove the excess material using hacksaw. 6. Mark the center as per dimension. 7. Set the job on drilling machine. 8. Make drill holes as per standard chart. 9. Make reaming, counterboring and tapping. 10. Make countersinking as per dimensions. Let us do in practical. Step 1. Collect the various materials like aluminum, copper and brass that cannot be less than 9 mm thick, 76.5 mm in length and 48 mm in breadth. Step 2. Hold the 3 workpieces against the angle block. Step 3. With the help of a vernier height gauge, mark the lines on the 3 workpieces. Step 4. First, place the workpieces in a vertical position and finish marking as per the dimensions given in the sketch. Step 5. Turn the workpieces horizontally and complete the dimension marking. Step 6. Make the punch marks on the workpieces with the help of the punch center and hammer at the marked junction to make drilling, tapping, etc. as per the sketch, so that cutting can be done easily. Step 7. Also, make punch marks in an extra area if found. Step 8. Unlock the bench vise using the lever. Place the workpiece between the jaws and tighten. Step 9. With the help of the hacksaw frame, cut and remove the extra pieces. Step 10. Do the same in all the 3 workpieces. Step 11. Place the job pieces between the jaws of the bench vise and start filing with the help of the file to smooth the workpiece. Step 12. Complete the filing process for all 3 workpieces. Step 13. Take a vernier scale, measure all workpieces' length, width and thickness and ensure that they are finished as per the given dimensions. Step 14. Fix the drill bit to the appropriate size, 6 mm as per the dimensions in the drilling machine chuck and tighten it. Step 15. Now place the workpiece in the suitable fixture and tighten with the lever in the drilling machine and make drilling. Step 16. In the same way, drilling is made in other workpieces for 6 mm. Step 17. Change the bit to a 12 mm replacement and drill at position B as shown in the sketch. Step 18. Fix the reamer tool in the drilling machine chuck and make a ream at position D for 6 mm as per the sketch. Step 19. Now replace the reamer with a 6 mm counter bore and drill at position A. Step 20. Make countersunks at positions C and H for 10 and 12.5 mm respectively in all 3 pieces. Step 21. Remove the workpieces from the drilling machine fixtures and fix them between the jaws of the bench vise. Step 22. Now that you have a drilled hole, use the correct tap size for cutting internal threads. To begin tapping, rotate the taper bit clockwise until you feel resistance from the threads cutting into the material. From there, for every full rotation clockwise, make a half rotation counterclockwise. Tappings are done at positions F, E and G for 10 mm, 8 mm and 6 mm respectively as per the given dimensions. Inspect all 3 workpieces after completing the process.
In this video, so far we have discussed marking out, cutting to size, drilling and taping the different materials like stainless steel, copper, brass and aluminum. I hope after watching this video, you can do this practical individually.
Hello students, this video is on the manufacturing process of an adjustable spanner covering the objectives, tools and techniques used. The process involves creating and assembling different parts of the spanner by using equipments such as a lathe machine, drill machine, files, reamers and rivet gun. The video also includes multiple choice questions to test the reader's knowledge of the tools used in the process. So, let us see the world of adjustable spanner production as we uncover the objectives, techniques and tools behind its creation. Spanner is the most important tool in the precision and craftsmanship. It is an essential tool and staple in every toolbox. At the end of this exercise, you shall be able how to prepare different parts referring to the drawing, prepare for assembly, assemble all the parts and check for the accuracy.
Vernier height gauge. Set of flat and round files. Hacksaw or chain drill. Drilling machine. Reamers. Radius gauge. Deburring tool. Vernier caliper. Lathe machine with necessary accessories. Cutting tools. Die nut. Metal sheet. Hammer. Punch. Bevel protractor. Knurling tool. Tap. Chamfering tool. Rivet gun. Countersink tool. Task 1. Part A fixed jaw. Check the raw material for the given size. File the surface and side for straightness. File the adjacent side for right angle. Do the marking as per drawing with vernier height gauge. Drill 10 hole for the R5 concave. Remove the excess material by hacksawing or chain drilling. File and check for the dimension as per drawing. Check the radius with radius gauge R5 and R3. Drill the hole 3.8 mm from the side to the depth of 12 mm and reinforce. Deburr and finish smooth surface. Task 2. Part B sliding jaw. Check the raw material for the given size. File the surface and side for straightness. File the adjacent side for right angle. Mark the job as per the drawing with vernier height gauge. Remove the excess material by hacksawing or chain drilling and fork to hole. File the job for the dimension and check the dimension. File for the radius edges and check with radius gauge. File the edges and deburr the jaw. Task 3. Part C special screw. Check the rod for 6 by 52 mm. Turn the rod holding in 3 jaw chuck for 4 mm, 10 mm length with H6 finish. Reduce length to 52 millimeters. Do the threading M6 for the entire length. Check with the die nut for threaded portion. Fixed jaw assembly. Insert the rod into the fixed jaw and position it. Drill 2 mm hole along with the fixed jaw. Fix the cylindrical pin too. Check the dimensions. Task 4. Part D. Sliding plate. Check the metal sheet for the dimension. File the sheet metal for straightness and right angle by draw filing. Mark the layout as per drawing and punch. Bend the sheet metal into right angle with the help of 6 mm flat by hammering. Check for the dimension after bending. Mark drill the 4 hole for the slot opening. Chain drilling for the slot opening, remove excess metal. File the slot for the dimensions. Mark drill 4 mm in the position as per drawing. File for 60 degrees angle and check with bevel protractor. Do the radius filing and remove the burrs part knurled nut. Check the raw material as per the drawing size. Hold the rod in the 3-jaw chuck. Turn the round for 1 mm. Knurl the outer surface with knurling tool up to 15 mm length. Drill 5 mm and tap the drilled hole by M6 tap. Chamfer the side to by 45 degrees. Do the parting off and chamfer the other side. Task 5. Spanner assembly. Check material size for all the parts. File, mark and finish parts A and B to size. Bend part D as per drawing. Remove excess metal and finish to size. File and finish square slot. Do countersinking for all drilling holes. Do turning, drilling, tapping, knurling and parting off the part E as per blueprint. Step turning, cutting external thread and parting off the part C as per blueprint. Assemble part C and A. Rivet and join part B and D. Assemble all the parts together as shown in the assembly drawing.
In this recap video, we will take a closer look at the objectives, techniques, machines and tools involved in this adjustable spanner. In this manufacturing process of the adjustable spanner, we learned about the objectives, techniques and tools involved. We explored the step-by-step creation of different parts, including the fixed and sliding jaws, special screw, sliding plate and knurled nut. The assembly process was also covered, highlighting the use of rivets and screws. Finally, we tested our knowledge with multiple choice questions, reinforcing our skills and understand the tools used in the precise craftsmanship. So, the topic emphasizes the steps involved in making an adjustable spanner. We explored the step-by-step creation of different parts, including the fixed and sliding jaws, special screw, sliding plate and knurled nut. The assembly process was also covered, highlighting the use of rivets and screws. Lastly, we tested our knowledge with multiple choice questions, reinforcing our skills and understand the tools used in this precise craftsmanship.
Today I'll be briefing you about the maintenance of military roads, particularly the flexible roads. First, coming to the failures of the road and their main causes. First, main cause is the aging and oxidation of the binder. Aging, as we all know, with time things get deteriorated, and certainly the